This is a quick video on triangle congruence, specifically side angle side. For the first problem, we are given pairs of triangles. Alright, see all the triangle pairs? And we're being asked which of these triangle pairs can be mapped to each other using a single translation. So in one of these pairs, you can move one triangle to the other by a single translation. Now understand that a translation is just a slide. So here I've copied the lower triangle. A translation would mean that my computer is going to glitch out, and of course it's not going to work. A translation would mean that I can move one triangle and make it match to the other simply by sliding it across the page like this. So clearly the first one is a no. There's no slide that's going to match the one triangle onto the other. So it's not that one. How about the second one? This is also going to be a no. Let me see if I can just get you to visualize it again. Remember, a translation is simply a slide. I cannot take one triangle and just slide it over and have it match the other one. This would take some type of a reflection, really specifically a reflection over the line CE. Now on the computer here, I can't exactly create that reflection. I can create something pretty close. Here I've reflected it, and that gets it closer. But hopefully you can see that this would take a reflection to map the left triangle onto the right triangle and get them to match up. So it's not the second one. Okay, let's see, what about these? It looks like another no. Alright, let's see if I can get you to visualize it. If I duplicate this triangle, there's no way I can just take this triangle and slide it onto the other triangle. So that's going to be a no. Alright, now look at the last pair. This is clearly going to be the answer. This is going to be a yes. And here I can show you why. If I copy the first triangle, now you can see I can get from the first triangle to the second triangle simply by sliding it over. That is a translation, and that's what we wanted. So that's why this is the answer. Alright, this next problem is very similar, but we want to be able to get from one triangle to the other using both a translation and a rotation, a slide and a turn. And the rotation needs to be about C. So the point C has to be the point that we are turning around. So this first one is going to be a no. This is not the answer, because all it would take to match the triangles together, I can move the top triangle onto the bottom triangle with only a rotation about C. If this is the center of the turn, if I were to rotate this triangle around, it would go from here and it would land on here. Alright, it would land perfectly with just a rotation, but it needs to be both a rotation and a slide, a translation. So that's why that one's a no. This one's going to be a no because we can make these triangles match with only a translation. With only a translation, with just a slide, I can map the one triangle onto the other. But again, they want a translation and a rotation. The first one, it was only a rotation. The second one, it was only a translation. We want both. This one's a no because it's a reflection. This one would take a reflection over this line to map the one onto the other. If I could take this and flip it, you know what, I think I can demonstrate that for you because of the way it's horizontal. So if I were to duplicate this triangle, now if I do a vertical flip, in other words a reflection, okay, see how the top triangle becomes the bottom triangle if I pick it up and turn it upside down, if I reflect it over this dotted line. Alright, so that's not what they wanted. They want a translation and a rotation, not a reflection. Okay, now how about this one? This one is going to be the answer because hopefully you can see that it will take some type of a rotation to get these two to match. But I can't start rotating now because these 2 points are not together. So what it's going to take is a translation to move point Z onto point C, and then a little bit of a rotation. Let me see how much of this I can demonstrate. If I copy the top triangle, alright, so here's the top triangle. If I want to move the top triangle onto the bottom triangle, first of all, you can see that a simple translation won't do it. If I just slide it down, that's not going to do it. But if I slide it down to the point where the Z point has been moved onto point C, if I make those points become 1 point, so I've done a translation. Now if I were to do a rotation around point C, the rotation would move this triangle onto the other triangle. So I can't do that perfectly on this computer because it just rotates around the center. It doesn't rotate around C, but hopefully you can just imagine, see as I'm like rotating, but I have to keep moving it around, so it's a little bootleg. But hopefully you can see that it takes this rotation. See this rotating that I'm doing? It's that rotation that it takes to get them to match. Okay, so eventually they will match, but I had to slide it down and then rotate. So that's what we wanted. A translation and a rotation. So that's why that's the answer. Okay? Once again, this problem is similar to the last two. Which of these triangle pairs can be mapped to each other using both a translation and a reflection? So we want a slide and then a mirror image reflection. Okay? You know what? I think this is the answer right away, the very first one. And let's see if I can demonstrate that for you. Alright, so I'm going to copy this triangle. Alright, so there's my copy. So first I'd have to slide it down to here. Alright, that's the translation that they were talking about. Alright, we had to slide it down so that we could match up with AB. Now it would be time for the reflection. If I were to do a reflection where this point was flipped over and landed on that point, alright, this triangle would turn upside down to where this is picked up and put down over there. These triangles would match perfectly. Now I can kind of demonstrate that by doing a horizontal flip, they call it, but then I have to quickly like move it over to show you. Alright, so you can see that they will match perfectly after I do that reflection where I've now flipped the triangle where a moment ago it was over here, but then we flipped it over and it landed here. So we did the slide and then the flip, the translation and then the reflection. And that's what they wanted. So this very first one is the answer. Okay, notice, so if you pick the second one, hopefully you picked it because you were seeing the reflection. Alright, if we reflect it so that point B lands on point Y, if we do that reflection, that's what it takes to map the one triangle onto the other. But they don't want it to just be a reflection only. They wanted a reflection and a translation. That's why the answer was the first one. Okay, here's the last problem for the video. So this is one where they give us a proof and they want us to fill in the missing statement. It helps to understand what's happening in the proof though. So we're supposed to prove that triangle MNS is congruent to triangle QNS. So triangle MNS is this triangle right here. Alright, and we're supposed to prove that it's congruent to triangle QNS, which is this triangle right here. Alright, so what are we given? We are given that triangle MNQ, alright, that's the large triangle, is isosceles with base MQ. So if this is an isosceles triangle where MQ is the base, then that means that these two sides will be congruent, alright, because the definition of isosceles. It also means that these two angles will be congruent because of the isosceles triangle theorem. Base angles are congruent. So we have sides, and we have a pair of sides and a pair of angles. Well, remembering that this unit, this section is all about side, angle, side. And here I've got a side and an angle. All I need is one more pair of sides and we'll have our side, angle, side. So let's see, there's more to the given. Maybe that will give us the information that we need. So they also say that NR and MQ bisect each other at S. So I'll just highlight this briefly. NR is this, and MQ is this. So we're told that they bisect each other. So bisect means that they cut each other exactly in half. So if they're cut in half, then that means that this piece is equal to this piece because it's bisected, it's cut in half. It also means that the top piece and the bottom piece are going to be equal, but I don't care about that because again we are looking for side, angle, side. And another reason why I know that is because if I look ahead for the bottom line of the proof, they say thus the triangles are congruent by side, angle, side. And we already had a side and an angle, so this is the other side that we need to complete side, angle, side. Okay, so let's follow that throughout the proof. We know that triangle MNQ is isosceles with base MQ, alright, because that was given. So therefore MN is congruent to QN, alright, that's these sides. By the definition of isosceles triangle, that's what we said. The base angles of the isosceles triangle NMS and angle NQS, that's these two angles, are congruent by the isosceles triangle theorem. That's what we said. So now here comes this other part where we say that these two sides are equal. Alright, watch out, that's all that's left. Let's see. It is also given that NR and MQ bisect each other at S. So the vertical segment and the horizontal segment cut each other in half, just like we said. Okay, so segments what are congruent? Well, we needed MS and QS to be congruent to each other. So we're looking for it to say something like segment MS is congruent to segment QS. Okay, by the definition of bisector. that would make sense. Therefore, side angle side. All right, let's see what it says. And there you go. MS and segments MS and QS are congruent by the definition of bisector.